Hi Josh. Let's solve this two problems in trigonometry. So number one, given that 4x is greater than 270 degrees and it's less than 360 degrees, and that cosine 4x is equal to 17 over 32. Find the values of cosine x, cosine 2x, and cosine 3x. And number two, prove the identity of, say it,
Sine to the fourth a, or sine quantity sine a to the fourth plus
plus
quantity cosine a to the fourth
is
equal
equal
to
to,
3/4 plus 1/4 times cosine 4.
okay. Let's start with number one.
Mm, okay. First solution yung the straightforward one. Straightforward. That's the pen color.
Yes, to
Blue, so it won't look
blue.
it will contrast with the question.
Okay.
Okay. So let's start from the cosine 4x. Cosine 4x is equal to cosine 2x. Then I will use the double angle formula for cosine. In particular, the cosine, the one that uses only cosines. So we can get cosine 2x. Minus 1. Now, I will again apply the double angle formula for cosine. Where minus 1 equals 2 times 2 squared x minus 1 squared minus 1. And then expands. Then again, distribute. Huh,
First,
it's not,
able to
it's not writing well.
on,
It's low button.
huh?
I think it's low button.
No, but hold on, let me connect. Screen. I use low but wait. Hold on. Oh, disconnecting the connector. Yes, can we try now?
Yes, we're oops, okay. Then, maybe I should put the equals here. Then, just simplify.
Combine the like terms.
Combine the constants especially.
2 and the 1, minus -1.
Okay, then thus, since cosine 4x was 17 over 32, we can equate this to 17 over 32. To make things easier, let's set uh, u equals cosine x, and then so let's just put u. But if I put the u here, uh, up in red, so it won't look part of the
Yes.
solution, actual solution. Now is
It will
setting
become
the cosine square cosine x only into u. Substituting, so u to the fourth plus 8u squared plus 1 plus
the fourth, can you make it minus square?
okay, sorry for 17 over 32. And then the 1 we transpose, or you know, the 17 over 32 we transpose. So it will become 2 plus 15 over 17 equals 0. And then we'll get the roots.
Put the sign here.
No, it's not
Ah,
equal.
yeah. So next step.
So I could have used the cosine squared x not equal to u, but it will involve another step anyway. So this is a biquadratic. It's not really it's a special type of quartic. So it's easier to solve than an actual quartic. It's a biquadratic. So
Okay, right there,
let's change
biquadratic form.
biquadratic.
So for those who are trying to learn,
Uh, yes, there are triquadratic and so forth. And those are also solvable. Those are those are one of the only. And then the bicubic, those are one of the only greater than quintic degrees that can be solved. So let's equals, I don't know, u squared. Then so not u squared minus 15 there plus 15 over 32.
so it becomes
Becomes a quadratic in the change of variable. The reason why I did not do u equals cosine squared x is it will be harder a little bit if you
Okay.
do it. So we will do it again anyway. So now we can use a variety of methods. I will just use the quadratic formula.
Put this one here. What here? Below. And
Okay, so this this is the quadratic formula. This is C. So negative 8 plus minus square root of b squared negative 8 squared. Oops, I said this aligned thing. Square root of 8 minus 4 times 8 times 15 over 32. As you may notice, it cancels perfectly. So the 4, the 8 will cancel with the 32. So that is 64 minus 15. That's 49. So 49.
so put there.
So
68 plus
wait,
minus
wait.
square root of
We
48.
still have 2a is 16. 2 times 8, 16. Okay. So 8 plus square root of 64 plus minus 15. Oh, I forgot the minus part. Over 16, that's equal to 8 plus minus square root of 49. over 16. And all we all know that is just yes, that is just 8 plus minus 7 over 16.
Yung next
Wait,
page.
wait, wait. And
Next page. So,
yes, it makes sense. Okay. So I was correct. Thought I made a mistake. So the roots of V1, that is 8 plus 7 over 16.
right there.
Wait, I will already write
Yes.
15 over 16.
And
And the V2 is the minus, that's just 1 over 16. And then we recall that set V equals U squared. So to get U, we have 4 values. Those are the solutions of the biquadratic. 1, this is square root of 15 over 16, which is in turn, we just separate the square root so we can simplify it. I mean, no, it's plus minus. We forgot the plus minus sign. So you can see here, it's very important. Actually, since I labeled that as U1, U1 or 2 is the plus minus, but U1, let's just set as the positive only. Okay. It's possible. So let's just set U1 as the positive one.
okay.
Then U2 will be the negative. Negative. Similarly, for U3, we'll use V2. That is the square root of 1 over 16. That is just 1/4, while the other was the negative root of the square root. Okay. Okay, so now,
So we have 4 values.
yes, we have 4 values. So now with these 4 values, we again, like earlier, I skipped a little. So we set u equals cosine x. So this is the part that is straightforward. It's actually evaluating the cosine inverse, and the principal solution to the cosine, and the other solutions, the rotational solutions. So start with U1, solving x for U1. No, actually, x with U1.
Right there.
I can't write x with U1. Which is square root of 15 over 4. So I will just put here the above the general formula, so don't have to continuously substitute. For every cosine x equals plus minus cosine inverse x plus 360 degrees k. For k is an integer. It's it's an element of the set of integers, or blackboard mode.
Put this down.
Yes. Okay, so now we will apply that here. We are going to get the solutions for cosine x is equal to square root of 15 over 4. So plus minus cosine inverse square root of 15 over 4 plus 60 degrees K. So when we do this, we first start, let's say, with the positive, arbitrarily positive cosine inverse, and then add 360 times 0. You can also do -1, but that's pointless because the cosine -1, the inverse, cosine inverse of any value will never be over 360, so your value will always be negative, so it's pointless in doing the -1. So you start from 0, then 1, then 2, and 3, then next try the negative. So in this case, we don't need all of the solutions because there's an infinite number of them. We just need to establish that there are none, or there are values in the range. Oh wait, before we start doing this first, I want to clarify something that is in the given that 270 degrees is less than 4x, which is less than 360x, we can deduce if the angle that we get, or the angles that we get, are either all of them not in the range or some of them in the range. So our basis for this is 270 degrees is less than 4x, which is less than 360x. 360 degrees, sorry. So x is less than 135 degrees over 2, or 135 over 2 degrees, and then it's less than 90 degrees. I just divided all both sides by 2, by 4. So we want that with this one is equal to, what's this again, 67.5, yes, 67.5. So if it's greater than 67.5 and less than 90 degrees, it is in our range. It's acceptable. But if it's not, we cross it out. So here, oops, since I blue. You can just use your calculator. If you want the old school way, just use your tables. So 14.477 degrees. Then this is when k is equal to 0. This is, of course, the plus, and the minus. Actually, the minus is pointless because if k was 0, then we would just have a negative value. Okay, so 14.477 plus and the 0. And then the next one's we will use the plus, and then k is now 1. And then the next will be 3, oops, hey, it crashed for a bit, 345.522 degrees. And then if we do the minus on this one, actually this one is it. This is the minus, and then we use the plus. We could use the plus on the cosine inverse and then add 360 is 1. That would be greater than 345.522, and then etc. Those are the bigger than 360. Of course, those will be bigger than 360 because if k is greater than 1, then we will be using 720. It will be very large, which is preposterous since we need only x must be less than 90 degrees. So these values are immediately crossed out, all of the k's that are greater than 1. So this 14.477 is less than 67.5. We can't accept that either. And that crosses out basically every single solution we have. So U cannot be equal to U1. Okay. So we try solving x with U2. So I will speed this up so we don't need a lot of explanation anymore. -1, and then U2 is the negative. The negative sign looks goofy. So yes, and then the plus 360 degrees. Okay. The direct inverse is 165.522. If you notice too, the cosine inverse always positive, so there's no point in using the negative value of the cosine inverse, the negative sign in this plus minus when k is equal to 0. So there's no reason. And then we use the negative in the 360 plus 194.477. Then after that is like earlier, we have values that are greater than 194.477. So it turns out 194.477, that's greater than 90. So trash it. And then 194.477 itself. And 165 is, of course, greater than 90. And of course, less than, it cannot be less than 67.5. So it's not even that. So U cannot be equal to U2.
U sub 2.
U sub 2.
Yes.
Okay, then
That
let's
gives us,
try.
let's
Oh,
try.
we still have two.
Two more.
Actually, even if one of them is
It's correct, but you
correct,
still have to check, right?
you still have to check what if there are two answers, or if you don't get three of them in your first try, what if the other one is actually not correct either? Maybe the question has no solutions. So we still have to try every single one. Just so cosine inverse, or I could just say our cosine. Maybe that would be simpler. Oh, oh, it switched somehow. Just the glitch. Interesting glitch. Oops. Plus 60 degrees 2. So I won't explain anymore.
Yes.
75.2 degrees. And the next one will be 284.47 degrees. Oh, I was not looking at the two up there. Okay. And then etc. Those are greater than 284.47, so we won't accept them. Neither is 284.47 within the acceptable range. But we have a contender here, this 75.52 degrees. It apparently seems that it's in the range. So we will look into U3 sub 3 because it works. So U can equal sub 3. In fact, U equals U sub 3, but we still have to check U sub 4. Maybe U has two solutions. We don't know. Solving. Okay. X is U4 sub 4. Still, I can't see the sub. Okay, so plus minus cosine first negative 1/4 plus 360 degrees.
Okay.
Equals 104.47. Oh, this kind of disappointing because it's apparently not in the range. So this leads us to an ideal solution finally. So there's only one value for U, which is U3. So U must be 1/4. So now we establish what were we looking for? So we have cosine X. That is 1/4. So I'll just put here was cosine X. Okay, we'll put a celebratory box. Yes. So we found one. Oh, what happened? So something's missing.
Okay.
Okay, so now we are done with the tedious process of getting cosine X. So now we will get the other ones. So now by this time it's only a matter of identities. we don't need to use those cosine inverse and checking each one. So now we will start with the easier cosine 2x. So using the formula I used earlier, it involves using only cosine. So the double angle formula for cosine has three uses. One of them is only sine, one of them is only cosine, one of them uses both. Use what you need. So here I need only cosine, I don't need sine. So there's no point in using the one with sine or the only sine. That would make it even worse. But I could also use it because sine squared x is directly related to cosine squared x. But this is easier. So we already know what cosine x is, so that is 1/4, 2 times 1/4, and then square minus 1. So this is remarkably easy. So 1/4, that's 2 times 1/16 minus 1, so that's 1/8. 1/8 minus 1 is equal to -7. Okay, -7/8. We immediately found it.
Yes.
So, early again.
What cosine?
Cosine x. So now we just need one more.
7/8.
Yes. We just need cosine 3x. So cosine 3x, as it so happens, is apparently cosine 3x is apparently equal to cosine 2x plus x. Of course, the 3x is equal to 2x plus x. So we will use the additive formula for general addition formula for cosine. So cosine 2x cosine x itself minus sine x sine. So the main thing to remember here is cos sine sine. You just use whichever order you want as long as they're the same in both. And then the sign, the plus or minus is flipped. It's the minus plus. So we know cosine 2x and cosine x, but we do not know sine 2x and sine x. Maybe we should have used that double formula anyway, but that won't stop me. So sine 2x, that is our double angle formula. So this is equal to 2 sine x cos x. Yes, so we know it involves cosine x, but we still need the sine x. So sine x, we find the relationship for sine x, and that is the very convenient sine squared x plus cosine squared x equals 1. So the best Pythagorean identity there is. It's used almost everywhere. So now we have a direct correlation. So sine squared x plus what's cosine x is 1/4, so 1/4 squared equals 1/4 squared is 1/16. So sine squared x is equal to 1 minus 1/16 or 15/16. So sine squared x is something we found already. Turns out sine squared x is sine x. Sine x turns out to be u1. It's a very funny result. So sine x is equal to square root of 15/4.
How did you get that?
Square root.
You show them. For those who are trying to learn.
What is the pads? Okay, square root of 15/4. So from here, sine x, we already found sine x. So we can substitute in the original addition formula, and then now we just find sine 2x. Sine 2x is 2 times sine x. So we already know sine x now. Square root of 15/4, and then times cosine x, which is 1/4. So 2 times 1/16 is the denominator. So times over 8. And then the square root of 15 is preserved. Square root of 15 over 8. Okay, good. So now we know every single thing we need to know cosine 3x. To know cosine 3x. So cosine 3x is again, cosine 2x plus cosine 2x, negative 7/8 times cosine x, which is 1/4, and then minus our newly found square root of 15 over 8, which is sine 2x, and then times square root of 15 over 4, which is sine x. So multiplying the square root of 15, square root of 15 is obviously 15, and then both denominators will multiply, it's 32, so that's just 32, and then, oh, it's happening. Anyway, so there's a cool bug, 7, negative 7, plus 15, so that is equal to, oops, wait, something, minus, so negative 7 minus 15, that is negative 22 over 22. Simplifying, we just cancel out 2, we factorize 2 and cancel it out. So that's negative 11. Yes, so we found the cosine 3x. So that completes our mission. Yeah, cosine 3x. Our mission is finally complete. So this is negative 11 over 16.
Yes.
Alternatively, we could have used a different method. This is reducing.
Put the line.
Oh yes, wait.
Put the line. Then you can use a different color. Let's say green.
Green. Okay. Dark green. Okay, sure. So this is an alternate solution. It involves using purely identity. So earlier, the downside of our technique is we used a calculator or tables. I consider that as you can't, if let's say, what if you have no calculator or no tables? So it won't be easy to do this. You have to do everything yourself. That will be very hard. So here we use purely identities, which means that we don't need to use any calculator, but it could ease our lives. So we will use the identity. I don't know what to call this. I'll just call it the identity method. Okay, so now we note the cosine 4x is known, so we can work from cosine 4x directly. Cosine, why did I do it uppercase? So that's weird. Cosine 4x is, I think we did that before. Yes, here we did this earlier. So I will just copy this one. Oh, it looks goofy. So the line looks goofy anyway. I'll just replace that there. So we will copy this one. Oh no, actually, we don't want the x. We want 2x, so we can solve for 2x first. And then we solve for x by halving it. We can also use the half angle formula. Maybe that would make sense. Yes, technically this is the half angle formula. Using only the double angle formula, we can still use the half angle formula. I don't really recall the half angle formula, so I'll just use double angle formula. We'll just work backwards. So this is equal to, at least I have a perfect equal sign.
Yeah.
Okay, so this is equal to cos. Oh wait, I mean, yes, I meant to say. Okay, 2 times 2x. So using the double angle formula again. You know what? I will just copy it directly. What's it? The underlined one. 2 cosine 2x squared minus 1. It's sort of a multiplication reduction. 2 cos 2x squared minus 1. Yes, I'm correct. Okay, so we know this to be 17 over 32. So this shall be 2 cosine 2x squared minus 1. 1, we transpose 32 plus 17, that is 49 over 32 is equal to 2. Maybe we can already transpose the 2. We'll just divide 32 times 2 is 64. So this is equal to cosine 2x squared. So how convenient, because it is squared, we need to square root it, and it turns out both the numerator and the denominator are perfect squares. So cosine 2x is equal to square root of 49 over 64. This, oh, it looks like 9. Alright. So, this is plus minus 7 over 8. Okay, so we have two answers. How do we? Yes, the inequality that was given. 270 degrees is less than 4x, which is less than 360 degrees. A different color in yellow or something else. This one. Yellow will look weird against the black background. Maybe I could use yellow. This is like this pinnacle of intelligence. Well, this is genius. Ha. So maybe I could. Yes, we can see it. Ha. Okay. I found the way. So what again? 270 degrees is less than 4x. It's less than 360 degrees. Dividing by 2 only, 2x. Then it's 135 degrees. And then this is 180 degrees. Good. Yes. Okay. Going back. Yes. So we will move this a little left. So since 2x is in between 135 and 180 degrees, let's draw a quick graph. Where's 135 approximately? That's like somewhere here, maybe somewhere here. Somewhere here, this 135, and then this is 180, of course. So it's somewhere here. So it's in the second quadrant. This is obviously part of the second quadrant. I mean, quadrant 2, not quadrant. Okay, quadrant 2. So if it's in quadrant 2, then cosine will be cosine is x. So if it's in quadrant 2, x is negative, so cosine is negative. So in this plus minus case, we take the negative value, which is negative 7. And in fact, we get the negative 70. Yes, negative 70 here. And here, negative 70. Good. So it matches. Somewhere there. Where is the? Okay, there. There's our. And
Can you turn to the next page?
Wait. Okay. So again, we will use a similar way of reducing the 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 factor of 2 by 2. Okay, so actually this is straightforward. When it's 2x, we just use the half angle formula or the double angle formula. I forgot the half angle formula for cosine. I think it's square root of 1 plus cosine over 2. Here. Cosine 2x equals, it's uppercase again, bro. Okay, so should be lowercase, or there's another use for it. Cosine squared x minus 1. This is negative 7/8 2 cos squared x minus 1, that is 8/8. So 8/8, a negative 8/8. So we transpose it to become 8/8. 8/8 minus 7/8. 8 minus 7/8, 1/8 is equal to 2 cos squared x. And of course, the 2 will go transpose to the bottom. 1/2 times 1/8 is 1/16 equals cosine squared x. Using similar methods, we will be able to find exactly the value of this rather ambiguous. I'll put the plus minus first. Plus minus square root of 1/16 plus minus 1/4. So again, we'll use similar means. 278 minus 1. This is 90 degrees. So again, we note that this is somewhere 65, 67.5. Yes, it's somewhere there. So graph again. 90 is greater, so this is the upper limit. And then 65 is somewhere here. So it is in here, which is obviously part of quadrant 1. So cosine will be positive.
Positive.
So this is positive 1/4. Okay. Cosine x is 1/4. Yes, it is 1/4. So what happened? Yes. Boxed. Mm-hmm. I don't know if the equivalent sign is appropriate here. Anyway. So now we
So
use. I think we will just use the same way. Cosine 3x, I'll just copy it.
Yes.
Oh wait, no. We do the exact same thing. We find sine 2x. I know, we find the formula of sine 2x. Actually, you don't need to do that. I was just illustrating it here. So we find sine squared x to get sine x. And then from there get sine 2x from sine x and cosine x. And then use the cosine addition formula to get cosine 3x. Yeah, so at this point we know cosine x and cosine 2x, which do the same. Basically, the only thing that mattered here was how I got cosine 2x and cosine x. I did it the opposite way. And then cosine 3x would be the same.
Yes.
Would be so it will all equal boil down to negative 11/16. It will be the same anyway. I'll just use the same method anyway. So I don't think there's a reason to elaborate on redundancy.
Yes.
So again, we have this.
So we'll just continue. We will just solve identity in our next video because so that it will not be, this video will not be too long.
Yep.
So we hope you learned a lot from this the solution of the two solutions of Joshua. Show your face. Let's get it proper. Yes. Thanks for watching.
Thanks for watching.